Have you ever thought about how you find a specific song on your phone?
Or,
Yeah, or like a particular email in your inbox?
mhm,
I mean, behind all that seamless searching, there's this
yeah,
incredibly powerful system for organizing information.
right. Oh, yeah, for sure.
And it's fascinating to think that those old library card catalogs,
Yeah.
rows and rows of those carefully ordered cards,
Yeah,
they actually share a fundamental goal with like the digital powerhouses that run our world today.
absolutely.
It all comes down to efficient information management.
It really does.
So welcome to this deep dive where we're going to unpack the core concepts of these digital organizers,
Yeah.
databases,
Databases.
and we're doing this specifically for you, someone who wants to understand how it all works
Right.
without getting bogged down in
Yeah.
all
Like
the
basically.
technical details.
Exactly the nitty-gritty. We
Yeah,
want to give you the big picture.
exactly.
So our goal today is to give you a solid understanding of what databases are, why they're so crucial in today's technology.
Mhm. And we'll introduce you to some key ideas behind relational databases and SQL.
Perfect.
We've got a really interesting mix of sources for this deep dive.
Yeah, we do.
We've got some academic materials, some Microsoft support articles, explanations from AWS.
Oh, and that YouTube video.
Yes, that YouTube video.
Yeah.
It does such a great job of laying out the groundwork.
Yeah, it's really helpful for getting a basic understanding.
For sure. So if you're looking to get up to speed quickly and thoroughly on databases,
That's what we're here for.
you've come in the right place. We'll pull out the most important insights and hopefully share a few surprises along the way.
Okay, so let's jump right in. What exactly is a database?
Well, in simple terms, a database is a collection of information that's stored and organized in a systematic way
Okay.
so that it can be easily accessed and used. The YouTube video we watched had a really clear definition.
Yeah, I did.
The key word here is systematic.
Right.
It's not just a random jumble of data. It's structured according to a plan.
A plan that determines how the information is put in, and just as importantly, how it's retrieved.
So it's about intentional organization.
Exactly. Intentional organization.
Yeah.
It's the opposite of just having data scattered everywhere with no rhyme or reason.
Right, like that professor in the video who is trying to keep track of grades on scraps of paper.
Oh, yeah, that was a perfect example. It's a recipe for disaster.
Total chaos.
Hmm.
So what's the fundamental difference between that kind of mess and a true database?
The difference is the system. With a true database, you're bringing order to that potential chaos.
Got it.
Think back to those library card catalogs we talked about. They weren't just piles of cards. They followed a strict system, alphabetical order subject headings.
Right.
That system made it possible to find a specific book among thousands.
And digital databases take that idea to a whole new level.
Exactly. They bring that concept of a system into the digital realm and make it much more sophisticated and automated.
And that's where computers and database management systems, or DBMS, come in.
Right.
The video touched on how they make things so much more efficient.
They're game changers. When you compare them to those old paper-based systems,
Yeah.
computers and DBMS offer huge advantages in several areas.
Like, what are the big ones?
Well, first off, efficiency gets a massive boost because everything storing, finding, and updating information is automated.
Right.
No more manual searching through files.
That's a huge time saver.
Absolutely. Then there's data integrity. You can set up rules within the DBMS to ensure the information is accurate and consistent.
So you're reducing the risk of errors.
Exactly. And as your needs grow, DBMS can handle massive amounts of data. You can easily scale up without things falling apart.
Okay, so that's scalability.
And of course, searching for specific information becomes incredibly fast and powerful.
Yeah, instead of digging through file cabinets, you can just type in a few keywords.
Precisely. You can perform complex searches in seconds.
So we have the database itself, which is the organized information.
Yes.
And then we have the DBMS, which is the software that manages it all.
Right. Think of the DBMS as the conductor of the orchestra.
Okay, I like that analogy.
It's the crucial link between you and the database.
So what exactly does a DBMS do on a practical level?
Well, it lets you define the structure of the database. You can create those organized tables, specify what kind of information each piece will be, and set up relationships between different sets of data.
Okay.
It also handles the actual writing of new data into the system, allows you to ask questions of the data to get specific answers,
Right.
make sure the data stays consistent by enforcing the rules you've set, and controls who can see and change what.
So it's like a highly skilled librarian for your digital information.
That's a great way to put it.
Okay, so we've got a handle on what a database is and the role of the DBMS. Now let's take a look at how we got to the kinds of databases we use today.
Sure.
The video mentioned those early magnetic tapes and then the big shift to relational databases.
Right.
What was that journey like?
Well, the evolution of data storage and computing is a fascinating story.
I bet.
In the early days, one of the main methods was using magnetic tapes.
Those big reels of tape.
Exactly, but there was a major drawback. You had to access the data sequentially.
Sequentially.
Yeah, like an old cassette tape. If you wanted a song at the end, you had to fast forward through the whole thing.
Oh, I see.
These were the early forms of what they called navigational databases.
And that sounds incredibly inefficient.
It was very time-consuming, especially compared to how quickly we can access data today.
So what changed the game? What led to a more efficient way of handling data?
The real breakthrough came in the 1970s with a researcher named Edgar Codd. He introduced the concept of relational databases.
Relational databases.
Okay. This was a revolutionary approach to organizing and accessing data.
And what made it so revolutionary?
Well, it was more efficient for one thing, and it became feasible thanks to the development of hard drives, which allowed for much faster direct access to data compared to those sequential tapes.
So no more fast forwarding through the entire tape.
Exactly. The key insight was organizing data in a way that minimized redundancy and improved consistency.
Okay, so relational databases, that's a term we hear all the time. What's the fundamental idea behind them?
The core concept is organizing data into one or more related tables. You can think of a table like a spreadsheet with rows and columns.
Okay.
Each row represents a single record, like a customer or a product, and the columns represent the different attributes or characteristics of that item.
Like a customer's name or address?
Exactly. What makes it relational is the ability to link these tables together based on the relationships between the data.
So for example, if we had an online store, we might have a customers table.
Yes.
And an orders table.
You're right.
And then some way to connect which customers placed which orders.
Precisely. You would have a unique identifier for each customer, like a customer ID,
Okay.
and then include that ID in the orders table. That way you don't have to repeat all the customer's information in every order they place.
That makes sense. It avoids a lot of duplicated information.
Exactly. It keeps things clean and efficient.
The PDF emphasizes that each row in a table has a unique identifier, often called a primary key.
Yes. That's crucial. It's what allows us to establish those links between tables.
Got it. The video also mentioned some key figures and companies that played a role in developing these ideas.
Oh, yes. The history of relational databases is full of interesting characters.
Can you give us a quick overview?
Sure. As the power of relational databases became clear, companies started building commercial database management systems. One of the pioneers was Larry Ellison, who founded Oracle in the late 1970s.
Oracle, big name.
Huge. Then in the 1980s, Microsoft entered the scene with SQL Server.
Okay.
And in the 90s, open source options like MySQL and PostgreSQL emerged.
So more choices became available.
Exactly. These open source systems made the technology much more accessible. It was a period of rapid innovation driven by the need to manage ever-growing amounts of data.
So we've traced the path to relational databases.
We have.
Now let's really dive into how they work.
Let's do it.
The PDF and the AWS explanation give us some more detailed definitions.
Yeah.
What are the defining characteristics of a relational database?
Well, as we've discussed, a relational database stores and provides access to related pieces of information based on the relational model.
Okay.
The key is that the data is structured in tables with each row or record having a unique identifier, that primary key.
Right.
The columns within the table define the attributes or characteristics of the data in each record.
So it's all about structure and relationships.
Exactly.
Yeah.
This well-defined structure with unique identifiers and clear attributes is what makes relational databases so powerful. It enables efficient searching and management of interconnected information.
Got it. The PDF also introduces the entity relationship model, or ER model.
Yeah.
Sounds like it would visually map out the blueprint of a database.
It is. It's a formal method for visually representing the relationships between different types of things in a database.
Okay, can you walk us through the main components of an ER diagram?
Sure. The PDF uses some helpful figures to illustrate this.
Sure.
So first we have the entity, which is represented by a rectangle in Figure 2. An entity is anything we want to store information about a customer, a product, and order.
Okay, basic building block.
Exactly. Then Figure 3 introduces a weak entity depicted by a double rectangle. A weak entity depends on another entity for its existence and doesn't have its own unique identifier.
So it's like a subcategory or something.
You could think of it that way.
Okay, what else?
Next, we have attributes, which are the characteristics or properties that describe an entity. They're shown as ellipses in Figure 4.
Attributes. Yeah.
And there are different types of attributes. Figure 5 shows a key attribute, also known as the primary key. It uniquely identifies each instance of an entity like a customer ID. It's represented by an underlined ellipse.
Okay, makes sense.
Figure 6 shows a composite attribute, which is made up of several other attributes. For example, a full name attribute might include first name and last name.
So it's a combination of attributes.
Exactly. Then there's the multi-valued attribute shown in Figure 7, which can have more than one value for a single instance of an entity.
Okay, give me an example.
Like phone numbers for a person. Someone might have a home phone, a cell phone, a work phone.
Right. Multiple values for one attribute.
Precisely. And finally, Figure 8 illustrates a derived attribute, which is an attribute whose value can be calculated from another attribute. A classic example is calculating someone's age from their birth date.
So those are the different types of attributes.
Yes, they provide a way to describe the entities in detail.
Okay, so we have entities and attributes. Now, what about how they connect with each other?
That's where relationships come in. They're represented by diamonds in Figure 9. A relationship describes how different entities are associated.
So the diamond shows the connection.
Exactly.
Yeah.
The PDF then outlines different types of relationships illustrated in Figures 10 through 13. We have one-to-one relationships where one instance of an entity is linked to only one instance of another entity.
Yeah.
A good example is a person and their driver's license. One person usually has one license, and one license belongs to one person.
One-to-one, got it.
Right. Then there's one-to-many relationships where one instance of an entity can be associated with multiple instances of another entity, like one teacher teaching many students.
Okay, one-to-many.
Then we have the reverse many-to-one relationships, where multiple instances of one entity are associated with a single instance of another.
Give me an example.
Think of many different products belonging to one specific category.
Okay, I see.
And finally, we have many-to-many relationships where multiple instances of one entity can be associated with multiple instances of another.
So going back to our online store example, many customers can place many orders.
Yes.
And many orders can contain many products.
Exactly. That's a classic many-to-many relationship.
These ER diagrams seem like really helpful tools.
They are. They provide a clear visual representation of how the information is structured and how different pieces of data relate to each other.
Okay, so that's the ER model. Now, the PDF also mentions Microsoft Access as a specific DBMS.
Yes, Access is a widely used DBMS.
It says it's good for creating relational databases from things like lists or spreadsheets.
It is. It's a great tool for that.
What's the advantage of using Access compared to just keeping data in a spreadsheet?
Well, spreadsheets are great for simple lists, but they can become problematic as your data grows and relationships get more complex.
I could see that.
You end up with redundant data, the same information repeated in multiple places.
Right, which can lead to errors.
Exactly. It becomes hard to maintain consistency. Access as a DBMS designed for relational databases helps avoid this redundancy.
Oh, I also.
It uses a process called normalization, where you break down the data into separate related tables.
So instead of one giant spreadsheet, you have multiple tables that are linked together.
Precisely. This makes the database more flexible, easier to update, and less prone to errors.
Makes sense. The Microsoft materials also outline the main components of an Access database.
They do.
Can you give us a quick rundown?
Sure. So first we have tables, which are where the actual data is stored. They're organized into rows and columns, just like spreadsheets.
Good, found.
Yes. Then there are forms, which provide user-friendly interfaces for entering and modifying data.
So they make it easier to work with the data.
Exactly. Forms often include buttons and other controls to streamline data entry and improve accuracy. The PDF highlights their importance for guiding user interaction.
Got it.
What else? Then we have reports, which are designed to present the data in a clear and organized way, often used for summaries or printing.
So you can extract meaningful insights from the data.
Exactly. Reports allow you to answer specific questions using the data.
Okay, then there are queries.
Right. Queries are powerful tools for retrieving specific data from the database based on criteria you define.
So you can filter the data and get just what you need.
Precisely. The material distinguishes between selection queries, which simply retrieve data,
Okay.
and action queries, which perform actions like creating tables or updating data.
So different types of queries for different purposes.
Exactly. And finally, we have macros, which are used to automate common tasks.
Okay. Like shrug.
You could think of them that way. And modules, which allow for more advanced customization and functionality using Visual Basic for applications or VBA.
So Access provides a whole toolkit for managing and working with data.
It does. It's a comprehensive environment for creating, storing, managing, and reporting on data.
All right, so we've got a good grasp of relational databases and some of the tools for managing them.
Yes.
Now let's talk about how we actually extract information from these databases and work with it.
Okay.
That's where SQL comes in.
It is SQL, or structured query language, is the standard language for interacting with relational databases.
The Microsoft material describes it as a computing language designed to resemble English.
Right. SQL is designed to be relatively easy to understand even for beginners.
And it's a language that database programs understand.
Exactly.
No.
It's specifically designed for working with sets of data and the relationships between them.
So it's the key to unlocking the power of databases.
You could say that.
The Microsoft source mentions that SQL is recognized as an international standard.
Yes, both ISO and ANSI have established SQL as a standard, which is great because it means that the skills you learn are transferable across different database systems.
So it's a universal language in the database world.
Pretty much.
And the AWS explanation points out that one of SQL's strengths is that its commands use common English words.
Yes, that makes it much easier to read and grasp.
Okay, the Microsoft article provides a simple example of an SQL select statement.
It does.
Can you walk us through that to give us a basic understanding of how it works?
Sure. The example is 10 squall select last name from contacts, where first name, Mary. This statement is asking the database to select the information in the last name field
Okay.
from the contacts table, where the first name field is equal to Mary.
So it's saying, show me the last names of all the people in the contacts table whose first name is Mary.
Exactly.
That's surprisingly straightforward.
It is. SQL can be very intuitive, especially for basic queries.
The PDF mentions SQL clauses as the building blocks of these statements. What are clauses and what do they do?
Clauses are like the different parts of a sentence. Each clause in a SQL statement has a specific role to play.
Go.
Some of the most common clauses are select, which specifies what data you want to retrieve, from which tells the database where to find the data,
Yeah.
which allows you to filter the data based on conditions,
Right.
order by which sorts the results.
Okay.
Group by why and having, which are used for working with summarized data,
Got it.
and union, which combines the results of multiple queries.
So each clause has a specific function.
Exactly.
And these clauses are made up of even smaller pieces, right?
They are. The Microsoft article mentions terms like identifiers, operators, constants, and expressions.
Right. Can you break those down for us?
Sure. Identifiers are the names we give to database objects like tables and columns, for
Okay.
example, contacts or last name.
Okay, so the names of things.
Yes. Operators are keywords or symbols that perform actions or comparisons like select from where and the equal sign.
Okay.
Constants are fixed values like the name Mary in our example.
So specific pieces of data.
Right. And expressions are combinations of these elements that can be evaluated to produce a single value.
Got it. So let's focus for a moment on that basic select statement structure.
Okay.
The Microsoft article explains the select from and where clauses in more detail.
It does.
Can you walk us through those?
Sure. So the select clause, as we saw in the example, specifies which fields or columns you want to retrieve. If a field name contains spaces or special characters, you enclose it in square brackets.
Okay.
The select clause is always the first part of a select statement.
Got it. Then comes the from clause.
Right. The from clause indicates the table or tables where the data is located.
Okay.
And then there's the where clause, which is used to filter the data based on specific conditions.
So it's like adding criteria to your search.
Exactly. The where clause is optional, but it's crucial for getting specific results.
Makes sense. And finally, there's the order by clause.
Yes, the order by clause lets you specify how you want the results sorted. You can sort by one or more columns, and you can specify ascending or descending order.
So you can customize how the data is presented.
Precisely.
It's interesting that SQL isn't just about pulling data out.
It's not.
The video mentioned that it also plays a role in putting data in and even defining the database structure.
That's right. While we've focused on using select statements to query data, which falls under data manipulation language, or DML,
DML.
SQL also has data definition language, or DDL.
DDO, got it.
DDL commands are used to create and modify the structure of the database itself.
So like creating tables and defining columns.
Exactly. Think of DML as the language for working with the data,
Okay.
and DDL as the language for defining the blueprint of the database.
DML for manipulating data DDL for defining the structure.
Precisely.
We've covered a lot of ground in this deep dive.
We have.
We've explored what databases are, how relational databases work, and we've gotten an introduction to SQL.
It's been a comprehensive overview.
So to sum up, databases are systems for organizing and retrieving information.
Yes.
Relational databases use tables and relationships to structure the data. And SQL is the language we use to interact with them.
That's the essence of it.
It's amazing to think how central these concepts are to our digital world.
It is. From the apps on our phones to global financial systems, databases are everywhere.
They're the invisible force behind so much of our technology.
Absolutely. Understanding these concepts gives you a new appreciation for how information is managed and used.
It really does.
Yeah.
It's like seeing the code behind the matrix.
Exactly. And this brings us to a final thought to ponder.
Okay.
Given our increasing reliance on databases to manage vast amounts of information, what are the implications for our society?
That's a big question.
It is. How do we ensure that this data is used responsibly, ethically, and for the benefit of everyone?
Those are important questions to consider as we move further into this data-driven world.
They are. The future of data management is full of possibilities, but also challenges.
It's up to us to shape that future in a way that benefits humanity.
I agree.
Well, this has been a fascinating deep dive.
It has.
Thanks for joining us.
My pleasure.
Until next time.
See you then.